Okay, so we're going to be talking about translations now. So the next transformation we're talking about is translations from the pre-image to the image. Now you may see something like this guy right here, okay? And then we're going to break this down into the different parts like we did with reflections. And maybe we're given something like this, like we talked about in the last video, where delta here represents a triangle, and we want to start with the triangle's pre-image and then move to its image, okay? Well, T, again, T, similar to when we were talking about the reflections, is the transformation name, okay? It's the transformation name. Okay? And it stands for translation. And remember, when we're talking about a translation, we're talking about being able to slide an object or an image, okay? So we're moving the object. We're not reflecting it. We're not rotating it. We're just sliding it, okay? And then this guy right here, if you haven't seen this before, this stands for a vector, okay? Now, if you don't remember a vector maybe from your science classes, a vector gives exact direction and distance. Okay, so a vector gives exact direction and distance, okay? So that's the part that is going to kind of direct us and where we're going to translate our pre-image to get to our image, okay? And then, of course, we said delta. Sometimes we're talking about a triangle. However, we don't only have to translate a triangle. We can move other pre-images to get to our image. But in this case, we're talking about the pre-image and then also the image. Okay, so remember we use the apostrophes to indicate our image, A prime, B prime, and C prime. Okay, now I'm going to go over one of these, actually two of these examples together, and we'll go over some of these examples together, and then we'll do the rest in class, okay? So in this first one, it says, describe with words where each vector is telling us to translate a figure, okay? Well, the first part of the vector here, this guy right here, this guy is going to either tell us left or right, okay? Left or right. So I'm actually going to make note of that over here, okay? So this guy's going to tell us left or right. However, left is going to be negative and right is going to be positive, okay? So left is going to be negative, right is going to be positive. So what do you think Y is going to do? It's going to tell us up and down, okay? Up and down. And then again, it kind of follows our thinking. Up is going to be positive and down is going to be negative. So left is negative, right is positive, up is positive, down is negative, okay? So in this first part here, we're talking about the X part. We're talking about the X part. That's going to be left and right. Now, since it's a positive value, it's talking about going to the right. So this means right 3, okay? Now, if I have 0 for my Y, what do you think is 0 means for the Y? Well, it means it's not going up, it's not going down, it just stays the same, right? Nothing's actually changing there, okay? So if we ever have a 0 either for the X or the Y, that means there's no change. It doesn't move left, it doesn't move right, it doesn't move up, it doesn't move down, okay? Let's skip B. We can do that one together in class. Let's work on number C here. So if I have 6 in the X spot, what do you think that means? Okay, so remember in the X spot, we're talking about left and right. Well, if this is positive, we're going to be moving towards the right, okay? Moving towards the right. So we're going right 6, and then remember in the Y spot, so that was our X spot, in the Y spot, that's talking about up and down. Now, if it's negative, we're moving down, okay? So this is right 6, and this guy is telling us we're going down 1, okay? So right 6 and down 1. So they're telling us how we're going to move our pre-image to get to our image. That's what these vectors are indicating there, okay? Then on number 2 here, we can use that information. Now we're actually dealing with a triangle. So remember, we have T for translation. They tell us the vector, and then what pre-image we're moving. In this case, we're moving JKH, the triangle JKH. Well, they tell us the vector there again. So remember, the X spot tells us we're going left or right. If it's positive, we're going to the right. So we're going right 2, and then Y tells us up, down. It's negative, so we're going down 3. down 3. Okay, so we're going down 3 and then right 2. So we can move each point with this given information. Okay, so let's move K. We're going to move it to the right 2, 1, 2, and then we're going to go down 3, 1, 2, 3. So our K primed, our image of our pre-image, K primed would be here. Okay, then we can also do the same thing with H. I can move H 1, 2, and then down 3, 1, 2, 3. So this guy right here would be our H prime, and then we can also do the same thing with J. To the right, 1, 2, and then down 1, 2, 3. So this guy over here would be our J primed. Okay, and then if we connect our points, whoops, there we go. Now I have my image. Okay, so this was our pre-image over here, this guy right here, and then K prime, H prime, J prime is our image. So we moved everything down here. We translated it 2 units to the right and down 3. Okay. Now there are different ways we can represent. That's the word I'm looking for. Represent how to translate things. Now we talked a little bit about vectors, but there's also coordinate notation. We did a little bit with the vector notation, and then we can also just flat out say what the directions are. Okay, so vector transformations can be written in coordinate rule notation. Coordinate notation helps us to see the connection between functions and their transformations, okay? So we can see how they actually move. But vector notation is more concise, okay? So sometimes we just use vector notation because it's just, honestly, it just looks nicer, okay? It's more concise. And then we also can just use the direct notation, just flat out tell you what we're going to use. But with coordinate notation, the way that works is exactly how you would think. Remember, the X tells us we're going left or right, and the Y is telling us we're going up and down, okay? So if I have X plus 5, what do you think that means? Right 5, okay? Right 5. If I have Y minus 1, what do you think that means? Remember, think up and down. Down 1. So this was right 5, and then down 1. Okay? Then, doesn't that match our vector notation? Remember, if it was positive, it was right 5. And then if it's negative for the Y, that meant down 1. Okay? So these are just two different ways to represent the same information, and then we could also just say it right 5 and down 1. Okay, so let's just go back and double check to make sure we know these. If I have X by itself, what do you think that means? If it's not adding anything or taking away anything, what do you think that means? It stays the same. No changes occur. It just stays the same. However, here we're adding 9 to Y. Remember, Y up and down. So what's that going to be? Up 9. Okay, so up 9. Then in terms of vector notation, this is how we'd write it. If you have a 0, that means there's no change here. So for that X coordinate, there's going to be 0 change. However, this 9 tells us we're going up 9 since it's positive, which is what they have here. Okay. Then, going back to this example here, if I have a minus 4 for my X, that's the opposite sign. Now, if I have a minus 4, what do you think that is? Left 4, and then a plus 2 for my Y would be up 2. Okay, so left 4, up 2. In vector notation, we use a negative to indicate that we're going to the left, so this would be left 4 because it's negative, and then since the Y coordinate is positive, that would be up 2. Okay, so remember when we're in vector notation, positive and negative in terms of, let's just go back up here. In vector notation, remember the X tells us left and right. Left is negative, right is positive. Y notation, the Y guy tells us it's either up, positive, down, negative. Okay, and it works the same on these guys, except they just tell us what we're adding or subtracting to it. Okay, so that's the coordinate notation, the vector notation, and of course we had left 4 up 2. Then let's actually look at some examples applying that. Okay, let's look at A and then maybe C. Okay, so they say convert the translation from one notation to the other. Okay, so in this case, they gave us the coordinate notation. They tell us we have x plus 1 and y plus 3, and we want to be able to tell both the vector notation and then just directly saying what it is. Okay, well, remember, if we're adding, okay, it's adding to x, that's going to be right. Remember, x is left and right. That's going to be right 1. Okay, that's going to be to the right 1. And then y is up and down, and since we're adding 3, that's going to be up 3. Okay, so we can tell right away that we're going right 1 and up 3. Okay, now that's what it is. Directly saying it out loud, that's what it is. However, in vector notation, how would we write that? Well, remember, right in vector notation is positive. So if it's going right 1, we just want a positive 1. Up is positive for our y value in vector notation. So if we're going up 3, we just want a positive 3. Okay, so this would be what it is in coordinate notation, vector notation, and then just directly saying it, we're going right 1, up 3. Okay, let's look at C. Now C is a little bit trickier because they give us the vector notation, but they don't give us the coordinate notation. So on C, we start with the vector notation. Okay, well, in the X category, it's 0. What does it mean if it's 0 again? That means there's no change. Nothing changes. It isn't going to the left. It isn't going to the right. There's no change. But in the Y category, we have a positive 6. Remember, Y is up and down. So if it's a positive 6, that means we're going up 6. Okay? So we can tell that it's going up 6. Okay? Now, in terms of a coordinate, how would we write that? Okay? Well, if there's no change in X, am I going to be adding anything to X? No. Am I going to be subtracting anything to X? No. So we just leave it as X. There's no change to X, okay? What about the Y? If I'm going up 6, how do I show that I'm adding 6 to Y? Exactly what I just said, plus 6 to Y, right? So that takes each Y value and adds 6, okay? So if we write a Y plus 6, we're referring to, I'm going up 6, okay? So this would be my coordinate notation there. X and then Y plus 6. Okay. Now we could also represent we can also use the vectors to kind of represent what we want to do in terms of a translation. For instance, if I look at this guy here, this is a vector. Okay, it's a vector because it's giving us the direct distance we're going to travel and then also where we're going. Okay, so it gives us the distance and the direction. So this guy is a vector. Now, notice they tell us that this vector is 1, 3. Well, what does 1, 3 mean? Well, in the X spot, remember X is left and right. They give us a positive 1, so this would be right 1. And then the Y spot is up and down. They give us a positive 3, so that would be up 3. Well, let's see if that matches what we have here in terms of the arrow. The beginning point is always the opposite end of the arrowhead. Okay, so the arrowhead is not where we start. We start right here. Okay, now let's count each point and see what it takes us to get to the arrowhead. Okay, so I can go up 1, 2, 3 spaces, right? Well, didn't we say in the vector we're going up 3? Yes. So it takes me up 3 spaces to get to the arrowhead, and then how far do I have to go to the left or right? Well, I have to go to the right 1 space. I have to go to the right 1 space to get to the arrowhead, okay? So I had to go up 3 spaces and right 1 to get to the arrowhead. So that's what they're referring to here, is that we can actually write a vector in terms of just drawing an arrow to represent the distance we're going to travel and where we're going to go, okay? So that's how these guys are related here, okay? For instance, if I look at this guy here, remember, we always start on the end opposite of the arrowhead, so our starting point is here. How far up do I have to go to get to the arrowhead? I don't have to go up at all, right? I don't have to go up. I don't have to go down. But what do I have to do? I have to go to the right, right? I have to go to the right 1 unit to get to the arrowhead. So in terms of a vector, what would that be? Well, if there's no change in X, remember, no change in X would be 0. And then if I have to go to, back up there. We didn't have to go up or down, but we did have to go to the right. So since I have to go to the right 1 unit, that's x. Remember, x is left and right. We had to go to the right 1 unit. That's a positive 1. However, there was no change in y. We didn't have to go up and down, so that would be 0. Okay, so let's see, double check to make sure this makes sense. Remember, x is left and right, and we had to go to the right 1 unit, so that's a positive 1. We didn't have to go up and down. There was no change. So since there was no change in up and down, we had 0 for y. Okay, so that would be our vector there. Okay, now let's also look at some other examples here, like example A, C, and D. Okay, so looking at these examples here, they say given a translation rule, determine the missing point. So we're either going to be given the pre-image and want to find the image, or we're going to be given the image and want to find the pre-image. Okay, well, let's start with this example here. Here we have a coordinate rule. They tell us we have x minus 6. Well, remember, x is left and right. So if I'm subtracting 6 from x, what is that going to do? That's left 6. That's left 6. Okay, then y is up and down, and we are subtracting 1 from y, so what is that going to do? Down 1. Down 1. Okay, so we know that it's going to take our pre-image and move it left 6 and down 1. Well, they give us the pre-image here, okay? So they give us a pre-image A, and that's going to take our coordinates -1 and 2, and it's going to move it to the left 6 and down 1, okay? Now, what we need to do is instead of thinking about plotting on a coordinate plane, we don't actually have to plot it on a coordinate plane and move it left 6, down 1. What we could do is literally just plug in these values for our x and for our y, and then see what we get when we plug it in, okay, to find our pre-image. So if I plug in those values, we'd have a -1 for x, -6, and then 2 minus 1. So all I'm doing is plugging in -1 for x and 2 for y, okay? Well, what's a -1 minus 6? Remember, same sign, adding keep your sign. So that would give me, writing it over here, a -7. And then what's 2 minus 1? 1. So when I translate it to the left 6 and down 1, my image, or my pre-image of A, -1, 2, moves to my image, -7, 1. So if they give you the point, all you have to do is plug it in for when you're given the pre-image to find the image, okay? So if you're given, maybe write this out to the side, given A, plug in your x and y. So if they give you A, and what I mean by A over here is we're talking about the pre-image, all we have to do is plug in the x and y to find the image, okay? Now, what happens though if instead of giving us the pre-image, notice this guy's blank, they give us the actual image? Well, then things just kind of work backwards, okay? So if given the image, so instead of the pre-image, we're given the image, do the opposite. So we're going to do the opposite of what we would think, okay? So let's first of all start off with C here and write down what we know is happening. In X, notice there's nothing being added to X, nothing is being subtracted to X, so nothing is happening to X. However, in the Y, or up, down, we're subtracting 4, so this would be down 4. Okay, so if we were given the pre-image, which we're not, if we were given this, all we'd have to do is plug in our point, and that would show us where we needed to go, right? However, we're given the actual image. So in a sense, we have to work backwards or do the opposite to get to the before picture. So we're given the after picture, and we want to find the before picture, okay? So if I had to move down, if I had to take this guy and move down 4 to get to this guy, what do you think I have to do to work backwards? Well, I have to go up 4, right? I have to go up 4. So in terms of plugging it in, what would be the difference between y minus 4, which is down 4, and then being able to go up 4? Well, I'd have y plus 4. The opposite would be y plus 4. So what we're going to do is the exact opposite. So instead of it being x and y minus 4, we're going to do x and y plus 4. Now I can plug in this point, and we're going to go backwards, okay? So we're going to plug in our 8 for x, and we're going to plug in our negative 5 for y. So when I plug that in, we would get 8 for x, and then when we plug in negative 5 for y, let's see what we get. 8 stays the same. That isn't going to change, okay? So in our pre-image, we'd still have 8, but what's a negative 5 plus 4? Well, that's different signs. So remember, we subtract and keep the sign a larger. 5 minus 4 is what? 1, and 5 is bigger and it's negative, so my answer would be negative, okay? So all we did was do the opposite to get back to the original image. Well, let's check to see if we're correct. Let's plug in our pre-image into the starting coordinate rule and see if we get what we want. Well, if I plug that in, I'm going to go off to the side here. Sorry, I'm moving around a lot, but let's go off to the side here. If I plug in 8 for x, we'd have 8. If I plug in a negative 1 for my y here, we'd have a negative 1 minus 4. And let's see if we get what we want. Well, 8 stays the same. Negative 1 minus 4, same sign, add and keep. 1 plus 4 is 5, and they're both negative. Okay, so I get 8, negative 5. So is that what we started with earlier? Yes. Okay, so remember, if they give you the image, the after picture, you have to work backwards, do the opposite. In our case, y minus 4 became y plus 4. Okay, now the last one I wanted to do was this guy right here, D. And in this case, they give us the vector notation. So it's the same thing, it's just the vector notation, okay? So now in this case, I'm told that the vector is a negative 1 for x. Remember, x is left and right. So if it's a negative, we're going left 1. And then in the y, it's up and down. If it's negative, we're going down 2. Down 2. And try not to get these guys mixed up there, but left 1 and down 2. Now, we're told that the pre-image is 9 and a negative 5, okay? 9 and a negative 5. Well, the nice thing about giving us the vector is literally, if they give us the image, all we got to do is follow what we have here, okay? I have to subtract 1 from my x, and I have to subtract 2 from my y. Simple as that. Just follow the vector, okay? I have to subtract 1 from my x and subtract 2 from my y. Well, 9 minus 1 is what? 8. And then a negative 5 minus 2, same sign, add and keep the sign. That would be 7, and then keep the sign, which is negative, okay? Then again, if they give you the after picture and we're looking for the before picture, again, we just do the opposite, change the sign, and do the opposite, okay? And we'll do that together in class. Last thing here, to determine the translation rule from the pre-image to the image, okay, let's look at this guy here. I'm told that I have my pre-image is negative 4, 1, and A prime, negative 1, 3 is my image. We want to write a coordinate notation rule that would get us from here to here. So we want to write the rule that will take us from there to there, okay? Now, the best way to do this is take your image minus your pre-image. So take your image minus your pre-image. So let's start off with that. Let's do the x first. The x, I would have to take a negative 1 minus a negative 4, right? So I'm subtracting the x values, a negative 1 minus a negative 4. Remember, when we subtract a negative, it becomes plus. Well, what's a negative 4 plus, or negative 1 plus 4? 3, right? So my x value should be 3. Now, we're not writing it in terms of a coordinate, so I should actually move that over, okay? Where did that go? There we go. Okay, because we're adding 3 to each x. So what that means is we're going to add 3 to each x. If we came out with a negative answer, it would be subtracting 3 from each x, okay? So we're writing it in coordinate notation. If we're writing in vector notation, all we'd have to do is put a positive 3, okay? But since we're writing it in coordinate notation, we're adding 3 to each x, okay? Now, same thing, let's do that with the y's. Take the image minus the pre-image, which would be 3 minus 1, which is 2. Well, what does that mean if it comes out positive? Well, we're going to add 2 to each y. Now, remember, in terms of vector notation, it would just be we're going +3 and +2. Whoops, that didn't come out right. There we go. But since they don't want the vector notation, we're working on coordinate notation. It'd be x plus 3 and then y plus 2. Okay. Oh, they do want the vector notation. What am I talking about? So it would be a +3 here and a +2. Okay. So anytime we want to write the rule, remember image minus pre-image, and that will get us where we want to be.